Hello everyone, I am Shurashree Pal. I am a Prime Minister's Research Fellow, and today we are solving this question from GATE 2020 examination Life Sciences paper Biochemistry, question number 19. Now, this is a numerical answer type question, and the question states an enzyme obeying Michaelis-Menten kinetics shows a reaction velocity V of 10 micromole per minute when the substrate concentration S equals its Km. The maximum velocity Vmax for the enzyme is blank micromole per minute, correct to integer number. Km is the Michaelis-Menten constant. Now, here for solving this question, we need to understand this Michaelis-Menten kinetics and what is the Michaelis-Menten equation. So, for following more details in the enzyme kinetics and the Michaelis-Menten equation, you can follow this NPTEL course, and the YouTube link of this lecture is also provided here. Now, this is the Michaelis-Menten curve. Now, this is a curve where we plot reaction velocity or the velocity of the reaction in the x-axis, in the y-axis, with respect to the substrate concentration in the x-axis. So this Michaelis-Menten equation stands on the fact that when there is an enzyme, it forms a complex with its substrate, and we know that substrates are specific to the enzymes, and the enzyme substrate complex then undergoes catalysis, and it produces the product, and releases the free enzyme. So basically the enzyme catalyzes the change of the substrate to product, and since this is a catalyst, the enzyme is free after the reaction, and the enzyme remains unaltered, right? And the substrate is converted to product. Now, we know that substrates bind to the active site of the enzymes, and when the substrate concentration is very less, so in this particular reaction, we are considering that the enzyme concentration is kept constant. Now, if the enzyme concentration is kept constant, when the substrate concentration is very, very low, then the reaction velocity will also be very, very low. But however, substrate concentration, when we increase the substrate concentration, the enzyme reaction velocity, the velocity of the reaction will increase, um, and it will increase till it reaches the maximum velocity, which is the Vmax. And at that point, there will be a saturation so that all the enzymes will be saturated with its substrates. And even if we increase substrate concentration more, so even if we add more and more substrates, the enzymes will all be saturated with the substrate. So there will be no increase in the reaction velocity. And that velocity, the maximum velocity, is called the Vmax, and the substrate concentration at which the enzyme or the reaction velocity reaches half of its maximum velocity, that is called the Km, or the Michaelis constant. So Km is the value where Km is the value of the substrate concentration when the velocity of the reaction reaches half of the maximum velocity, or the Vmax. Now, what is the Michaelis-Menten equation? So this is the Michaelis-Menten equation. It is V0, or the initial velocity, equals to Vmax into substrate concentration divided by Km plus substrate concentration. Now, this is the Michaelis-Menten equation that we will use for solving this particular question. Now, if we get back to the question, it states that this enzyme follows Michaelis-Menten kinetics, and it shows a reaction velocity of 10 micromoles per minute, where the substrate concentration equals to its Km. So basically, when substrate concentration is equals to Km, the reaction velocity is 10 micromole per minute. So we have already discussed that when substrate concentration is equal to Km, the velocity is half of the maximum velocity. So we can say that this 10 micromole per minute is half of the maximum velocity. Now, the maximum velocity is asked here, the maximum velocity or Vmax for this enzyme. So we can easily say that when substrate concentration is equal to Km, the velocity is half of the Vmax. So half of the Vmax is 10 micromolar per minute. So of course, Vmax will be double of 10 micromolar per minute or 20 micromolar per minute. So this is something we can solve very easily. That is 20 micromolar per minute. I'm just showing it to you once more, that when the substrate concentration equals to Km, it is given in the question, and it is also given the velocity is 10 micromolar per minute, which we know will be equal to half Vmax. So Vmax will be double 10 micromolar per minute, that is 20 micromolar per minute. Now, you can also solve this question from putting the values in the Michaelis-Menten equation. So this is the Michaelis-Menten equation. V0 equals to Vmax into S divided by Km plus S. So the velocity which is given, 10, you put it here in the place of V0. That is equals to Vmax into S divided by Km plus S. So in place of Km, you can put S, because it is given that substrate concentration is equal to Km. So in place of Km, you put the concentration of the substrate. So by calculating this, you can get Vmax into S divided by 2 into S. So if we cancel S on both sides, we will get 10 equals to Vmax by 2 or Vmax equals to 20. Or you can directly solve it from this particular information, that when substrate concentration equals to Km, velocity is half Vmax. So the answer here is 20. Okay, that's it, and thank you.